Okay, today we're adding to our rational function point discontinuities, which are holes in our graph. A point discontinuity is a graph is said to have a hole or a point of discontinuity at x equals a. The original function is undefined for x equals a, but the related rational expression in simplified form is defined. So that means in my original function, whatever x value we're looking at makes it undefined. But if I were to simplify this rational function, it would then be defined. Because of that, that makes it a hole versus a vertical asymptote. So you notice here, if we plug in an x value of -2, that would make my function undefined. So if we look at -2, my function would be undefined. So my domain would be, in inequality notation, x cannot equal -2. In interval notation, it would be, negative infinity to -2, union -2 to infinity. Okay, but in order to find the simplified version to see if this is indeed a hole, the very first thing we need to do is we want to factor the numerator and denominator. So my numerator would factor 2x plus 2, x minus 2. There's nothing to factor in my denominator, so we'll just have x plus 2. When we do that, we found our domain already. We want to reduce our function. So if you notice, I have an x plus 2 on the top and an x plus 2 on the bottom. Whenever something cancels out, if it cancels out, it's going to make a hole. So this is actually a hole at -2, x value -2. So anything that reduces, you could also say cancels. Anything that cancels will create a hole. Anything that's left over is going to be a vertical asymptote. But we don't have anything else on the bottom, so we actually don't have any vertical asymptotes. So we'll just say none. The x value of my hole is at -2. But we need to find the y value so that way later on when we go to graph, we can figure out where exactly that hole is on our graph. So to find the y value of the hole, we're going to plug the x value into the reduced function. So if we look at my reduced function, it's just x minus 2. So to find our y value, I'm going to say y equals -2 minus 2. So we plug in our x value of -2 into the x minus 2. I don't know why I have parentheses there. So we'd have a y value of -4. That means my hole is at -2, -4. Now, I went ahead and I graphed this in my calculator. So I've got x squared minus 4 divided by x plus 2. Now, I changed my window to be really zoomed in tight so that way you could see the hole. So if you notice, right here, this is the point -2, -4 if I turn the trace on. Okay, so it goes, I'm at -2.0. When I get to -2, it's undefined. There's actually a hole in my graph, and then it picks back up. Now, this is not a good way to constantly look at it because unless you're zoomed in super far, you're not going to be able to see it. So if I go back to my standard window, here I have my axes turned off, but just in my standard window, it completely disappears. So just wanted to show you that it exists, but that's not a good way to find it. So there's your hole. Example 2, same idea. This is the wrong example. Hold on. Okay, now I have the right notes. So when we look at example 2, very first thing we want to do is factor. You notice on my top equation, each term has an x, so the first thing we'll do is factor out the x. We'll be left with x squared minus 2x minus 3. On the bottom, both terms also have an x. We'll factor out the x plus 2. On the top, I still have the x squared, so it can actually be factored one more time. We'll have x and then x squared minus 2x minus 3. Multiplies to be -3, adds to be -2, would be x minus 3 and x plus 1. On the bottom, we'll have x plus 2. So when we look at this, finding our domain, things that make the denominator 0, we've got 0 and -2 will both make my denominator 0. So my domain would be x is not equal to -2 or 0. Going from least to greatest. Interval notation, negative infinity to -2, union -2 to 0. Got to get the middle piece, union 0 to infinity. So both ends in the middle. Our vertical asymptotes. Here's where we need to decide what are vertical asymptotes and what are holes. So if we notice, the x's cancel out. Things that cancel will be a hole. This is just left over on the denominator. Remember, our denominator is where our vertical asymptotes come in, so that will be a vertical asymptote. So vertical asymptote is here at -2, so x equals -2. Our whole, the x value is 0. To find the y value, we're going to plug it into what remains. So we've got x minus 3, x plus 1 over x plus 2 is what's left over. So when I plug in an x value of 0, we'll get 0 minus 3, which is -3. 0 plus 1 is 1. 0 plus 2 is 2, which would be -3 over 2, which is -1.5. So my whole will be at 0, -1.5. You can also leave that as -3 over 2. So we've got a vertical asymptote and then a hole in our graph. Third example we're looking at is we've got x cubed minus 4x over x squared plus 2x. So again, factor the top, pull out the x, that'll leave it with x squared minus 4. I'm going to keep going on the top. X squared minus 4 will factor 2, leave the x plus 2, x minus 2. You need to make sure it's fully factored so you're only left with linear terms. The bottom, when we factor out the x, leave it with this x plus 2. Same thing here. So on this one, things that make my denominator 0 be 0 and -2. Same thing again. So x is not equal to -2 or 0, -infinity to -2, union -2 to 0, union 0 to infinity. Okay, so now we're going to reduce. The x is reduced, which makes that a whole. X plus 2 reduces, which makes that a whole. So both of these things have canceled out, which means I'm not left with anything on the bottom. Remember, any leftovers are vertical asymptotes. There are no leftovers on the bottom, so we're going to have none. Okay, this is leftover on bottom. You might want to add that to your notes. Okay, no vertical asymptotes, but now we actually have two holes. We have a hole where my x value is 0, and we have another hole where my x value is -2. So we need to find both of those. Luckily for us, the only thing remaining is x minus 2. So when we graph this, this graph is actually going to look like a line. It'll be a linear graph because we only have x minus 2. There's just going to be a hole or two holes, one at 0, one at -2. Which is why that first function also was a graph, because we only had a linear term left over. So we're plugging into x minus 2, so we'll have 0 minus 2, which is -2. We'll have -2 minus 2, which is -4, because we're plugging into x minus 2. And there you go.